In colloquial language, an average is the sum of a list of numbers divided by the number of numbers in the list. In mathematics and statistics, this would be called the arithmetic mean. In statistics, mean, median, and mode are all known as measures of central tendency. Calculation. Arithmetic mean. The most common type of average is the arithmetic mean. If n numbers are given, each number denoted by I, the arithmetic mean is the sum of the i's divided by n, or the arithmetic mean, often simply called the mean, of two numbers, such as 2 and 8, is obtained by finding a value a such that 2 plus 8 equals a plus a. One may find that a equals 2 equals 5. Switching the order of 2 and 8 to read 8 and 2 does not change the resulting value obtained for a. The mean 5 is not less than the minimum 2 nor greater than the maximum 8. If we increase the number of terms in the list to 2, 8, and 11, the arithmetic mean is found by solving for the value of a in the equation 2 plus 8 plus 11 equals a plus a plus a. One finds that a equals 3 equals 7. Pythagorean means. Along with the arithmetic mean above, the geometric mean and the harmonic mean are known collectively as the Pythagorean means. Geometric mean. The geometric mean of n non-negative numbers is obtained by multiplying them all together and then taking the nth root. In algebraic terms, the geometric mean of a1, a2, and is defined as geometric mean can be thought of as the antilog of the arithmetic mean of the logs of the numbers. Example: geometric mean of 2 and 8 is harmonic mean. Harmonic mean for a non-empty collection of numbers a1, a2, and all different from 0, is defined as the reciprocal of the arithmetic mean of the reciprocals of the RS. One example where the harmonic mean is useful is when examining the speed for a number of fixed distance trips. For example, if the speed for going from point A to B was 60 km per hour, and the speed for returning from B to A was 40 km per hour, then the harmonic mean speed is given by inequality concerning am, gm, and hm. A well-known inequality concerning arithmetic, geometric, and harmonic means for any set of positive numbers is it is easy to remember, noting that the alphabetical order of the letters A, G, and H is preserved in the inequality. See inequality of arithmetic and geometric means. Thus for the above harmonic mean example, am equals 50, gm 49, and hm equals 48 km per hour. Statistical location. The mode, the median, and the mid-range are often used in addition to the mean as estimates of central tendency in descriptive statistics. Mode. The most frequently occurring number in a list is called the mode. For example, the mode of the list is 3. It may happen that there are 2 or more numbers which occur equally often and more often than any other number. In this case there is no agreed definition of mode. Some authors say they are all modes and some say there is no mode. Median. The median is the middle number of the group when they are ranked in order. Thus to find the median, order the list according to its elements' magnitude and then repeatedly remove the pair consisting of the highest and lowest values until either 1 or 2 values are left. If exactly one value is left, it is the median. If 2 values, the median is the arithmetic mean of these two. This method takes the list 1, 7, 3, 13 and orders it to read 1, 3, 7, 13. Then the 1 and 13 are removed to obtain the list 3. Since there are 2 elements in this remaining list, the median is their arithmetic mean. 2 equals 5. Summary of types. The table of mathematical symbols explains the symbols used below. Miscellaneous types. Other more sophisticated averages are trimean, trimedian, and normalized mean, with their generalizations. One can create one's own average metric using the generalized f-mean, where f is any invertible function. The harmonic mean is an example of this using f equals 1, x, and the geometric mean is another, using f equals log x. However, this method for generating means is not general enough to capture all averages. A more general method for defining an average takes any function g of a list of arguments that is continuous, strictly increasing in each argument, and symmetric. The average y is then the value that, when replacing each member of the list, results in the same function value, g equals g. This most general definition still captures the important property of all averages that the average of a list of identical elements is that element itself. The function g equals x1 plus x2 plus xn provides the arithmetic mean. The function g equals x1 x2 xn provides the geometric mean. The function g equals minus provides the harmonic mean. Average percentage return and CAGR. A type of average used in finance is the average percentage return. It is an example of a geometric mean. When the returns are annual, it is called the compound annual growth rate. For example, if we are considering a period of 2 years, and the investment return in the first year is minus 10% and the return in the second year is plus 60%, then the average percentage return, or CAGR, can be obtained by solving the equation times equals times equals times. The value of r that makes this equation true is 0.2, or 20%. This means that the total return over the 2-year period is the same as if there had been 20% growth each year. Note that the order of the years makes no difference. The average percentage returns of plus 60% and minus 10% is the same result as that for minus 10% and plus 60%. This method can be generalized to examples in which the periods are not equal. For example, consider a period of a half of a year for which the return is minus 23% and a period of 2.5 years for which the return is plus 13%. The average percentage return for the combined period is the single-year return, r. That is the solution of the following equation. 0.5 times 2.5 equals 0.5 plus 2.5, giving an average percentage return of 0.0600 or 6.00%. Moving average. Given a time series such as daily stock market prices or yearly temperatures, people often want to create a smoother series. This helps to show underlying trends or perhaps periodic behavior. An easy way to do this is to choose a number n and create a new series by taking the arithmetic mean of the first n values, then moving forward one place and so on. This is the simplest form of moving average. More complicated forms involve using a weighted average. The weighting can be used to enhance or suppress various periodic behavior, and there is very extensive analysis of what weightings to use in the literature on filtering. In digital signal processing, the term moving average is used even when the sum of the weights is not 1.0. The reason for this is that the analyst is usually interested only in the trend or the periodic behavior. A further generalization is an autoregressive moving average. In this case, the average also includes some of the recently calculated outputs. This allows samples from further back in the history to affect the current output. History. Origin. The first recorded time that the arithmetic mean was extended from 2 to n cases for the use of estimation was in the 16th century. From the late 16th century onwards, it gradually became a common method to use for reducing errors of measurement in various areas. At the time, astronomers wanted to know a real value from noisy measurement, such as the position of a planet or the diameter of the moon, using the mean of several measured values. Scientists assumed that the errors add up to a relatively small number when compared to the total of all measured values. The method of taking the mean for reducing observation errors was indeed mainly developed in astronomy. A possible precursor to the arithmetic mean is the mid-range, used for example in Arabian astronomy of the 9th to 11th centuries, but also in metallurgy and navigation. However, there are various older vague references to the use of the arithmetic mean. In a text from the 4th century, it was written that, in the first place, we must set out in a row the sequence of numbers from the monad up to 9. 1, 2, 3, 4, 5, 6, 7, 8. Then we must add up the amount of all of them together, and since the row contains 9 terms, We must look for the ninth part of the total to see if it is already naturally present among the numbers in the row, and we will find that the property of being 1/9 of the sum only belongs to the arithmetic mean itself. Even older potential references exist. This might have been calculated using the average, although there seemed to be no direct record of the calculation. Etymology. According to the Oxford English Dictionary, few words have received more etymological investigation. In the 16th century, average meant a customs duty, or the like, and was used in the Mediterranean area. It came to mean the cost of damage sustained at sea. From that came an average adjuster, who decided how to apportion a loss between the owners and insurers of a ship and cargo. Marine damage is either particular average, which is borne only by the owner of the damaged property, or general average, where the owner can claim a proportional contribution from all the parties to the marine venture. The type of calculations used in adjusting general average gave rise to the use of average to mean, arithmetic mean. A second English usage, documented as early as 1674 and sometimes spelled average, is as the residue and second growth of field crops, which were considered suited to consumption by draught animals. The root is found in Arabic as war, in Italian as avaria, in French as avarie, and in Dutch as average. It is unclear in which language the word first appeared. There is earlier, unrelated use of the word. It appears to be an old legal term for a tenant's day labor obligation to a sheriff, probably anglicized from avera, found in the English Domesday Book.